Hello, good afternoon, everybody. How are you all doing? Okay, nice to see you. A lot many of you have joined on time. Very good, very good. So, good afternoon, everybody. Welcome to my class. My name is Vaishali, and I'm your physics tutor for today. Okay, so my dear students, you can interact with me through the chat forum. I'm there with you in the chat forum also. So, let me say hi to you all in the chat forum too. Okay, so everybody, please do interact with me in the chat forum. So, hello, Sandeep, Priya, Prachi. Sure, yeah. Very nice to see you, everybody. Good afternoon. So, am I audible and visible to you all clearly? Very good, very good. Thank you. Thank you so much for the lovely feedbacks and reviews and the interaction that you are giving me in the chat forum. Very good to see you all. So, dear students, my name is Vaishali, and that we are going to take is a very interesting topic. So we'll be going to enjoy our class and also learn about a very interesting thing that we every day see in, and because of that only we are able to hear each other, right? So we can hear different sounds also because of the same topic that we are going to learn in today's class. Okay, and moreover this topic help us in many fields as well, right? So moving further, I will be exploring and giving you all the informations. So keep the suspense, what is the topic and how we are using it in our day-to-day life. We will be exploring more in our today's class. Okay, so let me share with you my screen so that you can see some visuals over there. You can see the pictures. Also, you can take the notes along with me when I'm explaining the concept, so that you have the important definitions, the formulas, and the concept to revise later again. Okay, so let's share. So here is the topic for today, that is physics of wave. Now, when I am saying physics of waves, what comes in your mind the first thing? Can you all tell me? Oh, yes. So the very interesting question first I would like to ask you is, what is a wave? Anyone? So when we are saying physics of waves, first of all, let me tell you what is physics. So do you all know what is physics? When you are studying physics subject, do you have an idea what we are, why we are studying physics? What is physics? Anybody? Yes, absolutely correct. Yes, yes, Ashutosh. So physics is the study of matter and even the energy, right? And then how this matter and energy affects each other, right? How this matter is affected by energy and energy is affected by matter. Uh, in areas like heat, light, electricity, sound, atomic nucleus, we can see this matter and energy, they are correlated and they are affecting each other. How we will be learning in higher grades also, and in today's topic also, as wave and light also and heat also and sound also, this all comes in this wave, right? So how they are created, they are because of the wave. Okay, so it also, this physics includes composition, characteristics, and processes also, different processes we include in it, and this study completely we do in the physics subject. So that is physics. Now, when I'm saying physics of waves, so we are going to study matter and energy, that is how waves are there to help us to do different things or to hear or to see different, say, matter is affected by energy. So one thing here I would like to ask you all, have you ever thrown a stone in a pool in your childhood or your children's right now also? So have you thrown a stone in the pool? Yes. Or how many of you have gone for a boat ride? Can you see the ripples over there in front of the boats? So what are they? Those are waves, right? Now, let me help you to do an activity, right? A very creative activity you can do, a very simple one. I'm not telling you to bring so many things. Just what you have to do: take some water in a tub, have a little bit more space, and throw a stone into it. Now, you all might be having a plastic ball, or I have a duck, a plastic duck, right? So what I done, throw a stone into it, and when the water will be in motion, what when you will be throwing a stone into it, the water will be in motion. right? And then put the plastic ball or the plastic duck over that water. What will happen? This toy duck or the ball, which you are placed in the path of the wave shape when the stone is thrown into the water, what is happening? Stone is thrown in water, energy is transferred to water from stone. Okay, so when a stone is thrown in a water body, right, energy is transferred to water. And when you place this plastic duck into the water, this wave which is moving, it is transferring some energy to the duck. So the duck is moving up and down from the mean position. So its mean position will be like this. But because of the waves which are coming in the water, this duck will be moving up and down from its mean position. Isn't it? So this is again a physics. Why it is happening? So due to elasticity and the inertial property of the matter, this energy is propagating and reaching to the place of where the duck is placed, and it is starting oscillations, right? So duck is oscillating, right? So understood? I hope you are enjoying. Okay. So when we are saying the duck is oscillating and because of the wave, so what is wave? What is wave comes in the mind, and how you can see the different type of waves, right? So physics of wave, you have might have got a little idea that what we are going to talk today. So moving ahead, everywhere we can see the waves. So light waves, heat, radiation, sound waves. So my dear students, if you have sometimes a very disturbing surroundings and there is a speaker going on, you might have experienced that the walls and the doors and windows, they are vibrating like this, isn't it? Why? The speaker is somewhere else, right? But still the doors and windows are shaking because of this, what we can say, the waves which are coming due to sound and is hitting our doors and windows, right? So this also starts vibrating. So when this drum has been hit, it starts vibrating, isn't it? So we have the radio waves, we have different type of waves, we have the light waves. This way we have waves, right? So waves everywhere we have. Isn't it a beautiful scenario? So do you go and enjoy somewhere outside on your vacations like this? So many of you might be having your summer vacations now and planning to go some outsides. Yeah. Okay. So tell me, where are you going to plan, and let me also have some idea where I can go and visit the places, right? Okay, so let's talk about today's topic. So I thought you all have gone to a mesmerizing place now in your virtual thoughts, isn't it? So come back and let's join and let's see what we are going to see in today's session. So in today's session, first of all, we will be understanding what is wave. Then further, we will be dealing with what are the types of waves in physics. So there are three types of waves basically: mechanical wave, electromagnetic wave, and matter waves. So in today's class, we will be in detail understanding about mechanical wave. Okay, electromagnetic and matter wave we will be talking in some other class. More than that, we will be talking about characteristics of wave also and understanding it, and then we will be understanding why these waves are important and applications of wave. Okay, so hope you are finding it very interesting. Yes, so let's see. First of all, what is a wave? So my dear students, waves, you can take a note over here. Waves, please take a note over here, right? So what are waves? It is a very important question that comes. So wave is a disturbance which carries energy and transfers from one place to another. But one magic is over here. It can do it without the particle going from one place to another, right? So the particle, it do not have to get itself displaced from here to here. Still, it will be transferring the energy from this initial position to this final position. Okay, so it can be in a form of elastic deformation. It can be in the form of variations of pressure, and elastic field of or magnetic field of intensity, etc. Right? So wave is a disturbance which carries energy and transfers from one place to another. It can be in the form of elastic deformation, variation of pressure, and electric field or magnetic field intensity, etc. Noted? This is very important, right? So we see these are the waves. Up, down, up, down. But what is the mean position? This is the mean position. Okay, so elastic deformation we are saying, so the particle, the matter which is there, right, so it should get deformed and come back to its original place. So this mean position it can achieve at the end of the day, right? Some pressure will be applied on the particle, that's why it is moving from its mean position to say to and fro and coming back to its mean position. Okay, electric field or magnetic field intensity might be affecting it so that it can have some motion or disturbance, right? That's why a wave is produced. So when I was talking to you, then we have to throw a stone into the water will start getting having some waves, or the particles of water, they are being disturbed and they started creating waves. Okay, so wave is a flow or transfer of energy in form of oscillation through medium, space, or mass. This is the simplified form of what is a wave, you can say. Hope you understood. Any doubt over here? No? Okay, then we will be moving ahead, right? So yes, so this is how we have waves. Now, let's move on to talk about types of waves in physics. So as I have told you, we have different type of waves. Sometimes we have the ripples like that. Sometimes we have the waves which are moving up and down. Okay. And now, have you ever gone through a slinky? Anybody have seen a slinky? Do you know what is a slinky? Anybody? Anybody know what is a slinky? The uh, bangle type structure that you might have seen, right? Bangle type structure that you might have seen somewhere, that you do like that, and then bangles are the much of the spring like structure, spring, right? So it is a spring, and then you play like this and then you throw and you catch it again. I will be showing you ahead, right? So that is the wave is going in this way. Some waves they go up and down, right? So there are different types of waves and they are creating different type of effects, right? So types of waves in physics, technically we can say they are firstly mechanical waves. Note it down. So we have, take a note, we have mechanical wave. This mechanical wave, I tell you, it require a material medium, right? It cannot travel through vacuum. Then we have non-mechanical wave, which we also call it as electromagnetic wave. This electromagnetic wave or non-mechanical wave, they do not require any material medium and they can travel to vacuum too. Okay. Further, we classify this mechanical wave as longitudinal wave and transverse wave. Then what are this longitudinal wave and transverse wave? We will be learning in today's class in detail, right? So let me tell you some examples of longitudinal and transverse waves. So sound wave. This is a type of mechanical wave. Light wave, water wave. Okay. So these are mechanical waves. Seismic waves. These are examples of mechanical waves. Okay, note it down. Moving further, when we talk about non-mechanical wave or electromagnetic wave, we have microwaves, X-rays, radio waves, ultraviolet rays, and infrared rays. Okay, so these are all non-mechanical waves. They do not require any material medium to travel. They can travel in vacuum too. So can you tell me any place where there is vacuum? Any place there where there is vacuum? In environment, we have air, they have particles, right? So matter is there, medium is there. In water, particles are there, medium is there. In solid, made up of particles, so medium is there. Any place there where there is vacuum? Anybody? Oh, yes. Yes, Dhruv, you got it correct. That is space, right? So in space, the outer world, that is out of our Earth's surface, we have different layers of atmosphere. Above that, there is space where there is vacuum. Then now I give you a think point over here, right? Then in space, if there is vacuum, then how light is coming on our Earth? Tell me. Think about it, right? So the answer is here only about the type of waves, right? Now, see, my dear students. Now, then, thirdly, we have the matter waves that you will be learning in higher grades, right? In quantum physics. So, the dual nature of matter, its ability to exist both as a particle and as a wave, was first given by or thought to light by the founder of the field of quantum physics. For example, a beam of electron can diffract just like any other beam of electromagnetic radiations or a water wave. Okay, so this don't go in the depth of it. We will be in your syllabus, we will be talking about mechanical wave and non-mechanical wave. In mechanical wave today we will be dealing in detail with um, longitudinal wave and transverse wave. Okay, so all of you have noted it. Shall we proceed? Okay, fine. Very good. Very good. So any doubt anywhere, please let me know. Okay. Yeah. So here we go. Next, first of all, after we have talked about the types of wave, let's talk about mechanical and non-mechanical wave moreover, right? So wave based on medium of propagation, we have mechanical and non-mechanical wave. Okay. So mechanical wave, as we have understood, needs medium to propagate. Non-mechanical wave doesn't need a medium to propagate, right? So needs a medium to propagate. So what will be the medium to propagate? And if doesn't need a medium to propagate, then see, our Earth is here. So solar radiations are coming to our Earth, right? So there is vacuum. They are directly coming to our Earth, isn't it? Yes. So I have a question for you all. Can you all try to answer this? Then we'll be moving ahead. Okay. Yes. So the question is, choose 1 second. Yes. So question number 1 on your screen is over here. Choose the location of the rocket where the sound of the rocket can be heard. So you have 3 locations given: P on the surface of Earth, Q in the atmosphere, and R in the space. Now, can you tell me where the rocket sound you can hear? You can all answer me in the chat forum. Okay, that's cool. Very nice. So most of you are getting it correct. Yes, so the answer is option number C, P and Q. P on the surface, so we will be having the medium as air, right? And in the space, again, we will be having the medium. That will be the particle medium of atmosphere. But in space, we won't be having any medium. So we won't be able to hear the sound, right? So rocket sound, we won't be able to hear in R. We can hear in P and Q. Very nice. Interesting, isn't it? Now, so hope you are enjoying, and any doubts, please do ask. Here we go ahead on the next learning. So as we have understood from this question very clearly, we require material medium to travel, right? So waves provide this material medium, and the energy is transferred from one place to another. Say, for example, we have sound. So, how sound is traveling? With the help of solid, liquid, and gases, right? So, waves require a material medium to travel. They are mechanical waves, right? So, they can travel through solid, liquid, and gas. So they require matter. The property of the medium should be they should be elastic, must have inertia, gas, and frictionless. Okay, so this way we have medium in the mechanical wave. Now, as I told you to think, how is light traveling from sun to earth? Any answers? Because of the non-mechanical wave, right? And also you might be using the television remote control every day, right? So it has a light over there again. Okay, so this remote control which you are using, it has a little bit bulb over here which helps this wave to travel to the remote to the TV, and the TV is operated accordingly, right? So this is again controlled by remote, and the some waves might be there which might be reaching to the television, and it is working. Okay, so this we will be exploring more in now. Okay, so here we go. So mechanical wave, first of all, let's talk about it, and you can take a note on it. What are mechanical waves? So waves which need a medium to propagate are called mechanical waves. I repeat, the wave which needs medium to propagate is called as mechanical wave. The speed of mechanical wave depends on elastic and inertial properties of the medium. So you all know what is inertia, right? Newton's law, remember? So an object wants to be in its place, right? It is lazy until and unless some external force is acting on it, isn't it? And or object want to be in motion until unless some external force is acting on it, right? So example, wave on a string, sound wave, etc. are the mechanical waves. Now, as we have talked, mechanical waves are of two types classified: longitudinal wave and transverse wave. First of all, let's understand what are longitudinal waves, right? So see, longitudinal waves, as I told you, is spiky, right? So this is spiky. What happens? You can move the spring easily like this and like up and down, okay? So the waves in which the particle of the medium vibrate in the direction parallel to the direction of propagation of wave is known as longitudinal wave. When I'm saying parallel to the direction of propagation, then what we are understanding from here? So the direction of wave is this. Okay, wave is moving in this direction, and the particles, see, say this is a particle. So this particles, its mean position is this, and it will be moving to and fro. That is front and back from its mean position, coming back to its mean position. Okay, so that is the particle motion will be parallel to the direction of propagation of wave. Now here it is, there is something written as compression and rarefaction. Have you noticed? So what is compression? So compression is the region of high density, right? High density of the particle, and rarefaction is the region of low density of particle. So you can see the area of slinky over here. You can see the springs are more, and here you can see the spring are apart from each other. Okay, so where the springs are closer to each other, there will be high density, and even these springs will be applying some pressure on each other to vibrate from its mean position, right? So that we call it high pressure region, and rarefaction, low pressure region. Okay, so compression is a region of particles where the density of the particles and the pressure on the particles is high, and rarefaction is the region where the pressure and density of the particle on the particles is less. Got it? Noted? Understood what is longitudinal wave? Now, moving ahead, let me tell you what are longitudinal waves as pressure wave. So as I told you, high pressure, low pressure, right? So we have talked about density and density and density of the particle and pressure of the particle, right? So wave as pressure wave. So when we have heard sound, right? So wherever we have the speaker, just near to the speaker, the particles of air, they will be, say, more. And then when they will be vibrating and they will be striking to each other, they will be creating some pressure on each other. Okay, understood? So they are creating some pressure on each other. So because of this vibration, this particle will be pushed ahead and the next particle will again be applied some pressure and will be again coming into motion. So the particles where the density, the place where the density of the particles is less, we are calling it as rarefaction region. So we can make a graph of pressure and density versus distance of the wave which is traveling. Okay, so here you can see where the density of the particles is more, we call it as compression, and we are getting a crust, right? So wave is going upside, and where the density of the particles are less, the wave is going downwards. That is rarefaction region. Okay, so we can say the trough is the region of low density and low pressure, and crust is the region of high pressure and high density, or we can say compression and rarefaction region. Understood, everybody? You can take a note of it. Now, let's talk about transverse wave. So, what are transverse wave? So, a wave in which the particles move in the direction perpendicular to the direction of motion of the wave is known as transverse wave. Now, what you can do is you can take a rope, hold it from your one end, right? Take a nice rope and then move it up and down, right? So, what will be having? The rope will be creating some waves, and this wave will be, when you will be starting up, it will be going up to down. The further the waves will be created. Try doing this, right? So you will be getting a transverse wave. So wave is getting transverse. Okay. So here you can see the displacement and distance of the wave. So displacement, the particle is over here, right? It is moving up and then down. So the direction of propagation of wave is in this direction, in this way. Okay, and the particles, they are moving up and down, making the forming the wave over here. So this is the crust and this is the trough. Got it? So one oscillation is completed when one crust and one trough is formed. So one oscillation will be one crust and one crust trough. So we will be getting one complete oscillation. Understood, everybody? So this is how we have transverse wave. Now, moving ahead, let's talk about the characteristics of wave. So see, sound waves have different characteristics. So we have to understand the waves, right? So waves, as we are talking about crust and trough, let me explain you over here what is the time period. So as we have understood, one wave is equals to one crust plus one trough, right? So we'll be having one wave like this. Or we can consider from one crust to another crust, we have a one wave, that is wavelength. So wavelength is defined as the distance between the consecutive crust or trough. Its unit is meter. Time period is the time taken by, say, a particle to complete one oscillation. Its unit is seconds, denoted by lowercase s. Frequency is the number of oscillations in 1 second. Say, for example, we have this time distribution, say 1 second, 2 second, right? So, how many waves are there in 1 second? So that is the frequency. So we have a relation between frequency and time period, that is F is equals to 1 by F. So to take a note of it, important concept. And amplitude is the maximum displacement of a particle from its mean position. So mean position will be along this line, right? Here we can say x-axis. But the particle will be moving to and fro from the mean position. So that is the amplitude. So maximum displacement that the particle will be moving from the mean position is the amplitude. So SI unit is meter. Also, this wave, when it is moving, it will be having some speed. So this speed is given as frequency multiplied by the wavelength. So it is very, very important formula. So frequency multiplied by wavelength. So U is equals to F into lambda. So lambda is used, symbol used to denote wavelength, and F, lowercase f, is used to, symbol used to denote frequency. Uppercase T for time period. So now we have understood the characteristics of wave. So this way we are now on the importance of waves. So see, my dear students, importance of waves when we are saying, so these waves have utility. As we are able to speak, so we have the sound waves over there. So my sound is reaching to you all, or when we are speaking to each other, sound waves are reaching to each other, right? So sound waves are longitudinal waves. Okay. Light waves are what type of waves? Transverse waves. Okay. And importance of waves, as you can see, it is used in weather forecasting. Ocean waves are important for climate modeling and weather forecasting. So transferring energy from one place to another without a displacement of matter is waves, right? So waves are used in many, many areas. Communication also. So radio waves, which satellites are giving, and we are getting this waves, and communication is happening. We have the broadcasting. Okay. Broadcasting also, on televisions we can see the movies, very wonderful cartoons and all we are able to see because of the broadcasting, which is happening because of this waves, right? So we have the communication waves, we have the verbal communication. For that also we require wave and radio wave, or moreover mobile phones. Also it is used in medical places, right, for healing the wounds. Somewhere you can see have you heard of ultrasonography? So ultrasonography is done uh, to know about the human being's inner parts, right? Inner body. If there is any defect or any problem, any disease to be defected, in any disease to be found, right? So that is ultrasonography is done. Then detecting obstacles like in sonar. So this is used by military services also, or the ships also. So ships, they send this sound waves, sonar waves in the ocean or in seawater, and that can help them to detect whether there is any obstacle or how much distance is there of the seabed from the ship, right? So this way sonar waves are used, radio waves, mobile phones it is used. In photography also, light waves are used in indoor and Nighttime photography is there, so light waves are used. Ecosystem, so waves help distribute oxygen and nitrogen throughout the ocean, supporting marine life. Also, shape coastlines, provide habits for plants and animals. This all are the places where waves are used. Moreover, waves are also used by some animals to detect their prey, like the bats. They use it to detect their prey as moth. Okay, so this way bats also use the waves. So you tell me ultrasound or infrasound? That we will be learning in some other class. Okay, so yes, this way we have waves and their application. So with this, we are towards the end of our class, right? So let's summarize what we have learned. Any doubts if you have, you can put in the chat forum so that I can clear it out. So yes, in today's class, we have learned about what is waves, right? What are the types of waves? So we have mechanical waves as well as non-mechanical waves. Mechanical waves are further divided into transverse wave and longitudinal wave. So mechanical wave needs medium to propagate, and non-mechanical waves do not require any medium to propagate. They can travel in vacuum too. So transverse waves, particle vibrates perpendicular to the direction of propagation of wave, as we have understood. So wave is propagating in this direction, x-axis say, the particle will be moving to and fro perpendicularly to the wave. And in longitudinal wave, the particles vibrate parallel to the direction of propagation of wave. So we can say the transverse wave is the light wave and longitudinal wave is the sound waves. Okay. Moreover, we have also understood what is compression, so region of high pressure and high density, rarefaction, region of low pressure and low density. So you can see here a person is playing a guitar and the sound is going over there, right? So there is a region of high pressure, low pressure, isn't it? So we have crust and trough. We have understood about the characteristics of the wave, wavelength, time period, amplitude, frequency. Okay. So with this, let's end up our class for today. We will be meeting again in some another class, right? So thank you so much, everybody, for joining. See you again, right? I hope you enjoyed the class. Thank you. Bye-bye, everybody. Good day. Take care.